This presentation is on microwave assisted reactions. Microwave synthesis opens up new opportunities and is a potential tool of green chemistry. Microwave is a form of electromagnetic energy. Electric field is responsible for heating. It corresponds to wavelengths of 1 centimeter to 1 meter. Here are some advantages of microwave over conventional heating, such as less reaction time, higher yield with higher purity, better reaction kinetics, higher energy efficiency, and so on. In microwave heating, the reaction mixture is homogeneously heated and consumes lesser energy, whereas in conventional heating, heat is transferred from surface to reaction solvent and then to species, making it less efficient. Here are some advantages such as higher temperatures, faster reactions, lesser byproducts, energy efficient, rapid energy transfer, and so on. It has few limitations like it is limited by solvent which reach boiling point is less than a minute. Precautions such as volatile reactants under superheated conditions may result to explosions. Prolonged exposure can degenerate body tissues and cells. For dipolar polarization, substance must have dipole moment. Frequency for interparticles should be adequate. Required range 0.3 to 30 GHz. Second mechanism is ionic conduction. It generates heat through resistance to an electric current. Microwave assisted reactions in water. Water is a readily available, non-toxic and non-flammable green solvent. In Hoffman elimination, use of microwave irradiation has led to high-yielding synthesis of a thermally unstable Hoffman elimination product. Methyl benzoate in aqueous sodium hydroxide under microwave conditions gives 84% yield of benzoic acid. Oxidation of toluene with KMnO4 in microwave conditions takes only 5 minutes and yield is 40%. Primary alcohols can be oxidized to carboxylic acid using sodium tungstate as catalyst in 30% aqueous hydrogen peroxide. Secondary alcohols can be oxidized under microwave irradiation by using doped supports like clayfen, silica manganese dioxide, etc. These are the reactions in which organic solvent is used to assist the reaction. One of the example is Diels-Alder reaction which involves 1,4 addition of an alkene, malic anhydride to a conjugated diene, anthracene, to form an adduct of a 6-membered ring. Diglime is used as a solvent. 80% yield is obtained in 90 seconds. Conventional decarboxylation involves refluxing in quinoline in presence of copper chromite and yield are low. In presence of microwaves, it takes place in a much short time. The Hack reaction between idobenzene and methyl acrylate was successfully modified for microwave assisted synthesis. Even though the conventional transformation to product requires the reaction to be heated at 80 degrees Celsius for 20 hours, it can be achieved in just 5 minutes at 170 degrees Celsius when microwave irradiation is used. As well as extensive savings to the reaction time, the high temperature, high pressure capabilities of the Discover SP enable the reaction to be performed in a solvent free environment, thus minimizing the amount of waste produced.